Hey, welcome back. In this video, we're going to talk about vectors and how vectors can represent either a direction or a position in a 2D space. We'll talk about how vectors can be used to facilitate movement in our video game. Let's get started. Now, a vector is a mathematical quantity with two main properties, a direction and a magnitude, represented by the length of a vector. Now, vectors can be broken down into components. A two-dimensional vector has an x component and a y component. That's why Raylib's vector2 type has an x and a y variable. Together, the x and the y combine to make the vector. Think of the x and y as the distance you'd have to travel in the x and then the y direction in order to get to the end of the vector. If we know the values of the x and the y components, how do we get the length of the vector? Well, notice hidden in the diagram here is a right triangle. And this is the key to finding that vector length. You see, we can find the length of a vector by using the mathematics of right triangles. Say we have a triangle with sides A and B, and side C is the side opposite the right angle, also known as the hypotenuse. It just so happens that there's an equation relating these three quantities, and it looks like this. Now, let's say that A and B are both 1. Then that means C is related to those quantities with this equation. Now, this is not a math course, so I'm not going to make you solve equations, but if you did, you'd see that C is roughly equal to 1.414, or the square root of 2. So this is how we can find the length of a vector if we know the x and y components. Now, vectors represent a direction, but they can also represent a position in space. Let's say we have a character in 2D space and it has its own position. We've seen in Raylib that a position can be represented by a 2D vector. We can think of that position as a vector from the origin to the object in question. Now, let's say we want to move this character in the direction represented by this vector called move. How do we figure out this character's new position? The answer is by vector addition. You see, the pos vector plus the move vector is equal to new pos, which is the vector from the origin to this new position. Now, in order to add these two vectors, we would perform what's known as component-wise addition. The new vector's x would be equal to pos.x plus move.x, and y is calculated similarly. So if we add these two vectors together, the character's new position will be the sum of the two vectors. In general, if you have a vector A and a vector B, and you place B such that its tail is at the head of A like this, then A plus B is equal to the vector from the tail of A to the head of B. Here's an example. Now here I have a horizontal axis and a vertical axis. Let's say I have a vector with its tail at the origin and its head at the point 2, 1. So the vector's x and y components are 2 and 1. Now I have another vector with its head at the point 1, 3, so its components are 1, 3. Now let's say I want to add these two together. So I can move the vector 1, 3 so that its tail is at the head of the vector 2, 1. Here's the vector that represents the sum of 2, 1 plus 1, 3. Notice it's the vector 3, 4. Its x is the sum of the x components of the first two vectors, and its y is the sum of the y components. If you wanted to subtract two vectors, a and b, then you'd simply need to take negative b, which is the same as b only pointed in the opposite direction, and then simply add these two together. So a minus b is the same as a plus negative b. There are many different vector operations, and Raylib contains a math library called Raymath, and you can use it by including the header raymath.h. Some functions in this library include vector2add, which takes two vectors, adds them together, and returns a vector that is the result. Likewise, there's vector2subtract, which takes two vectors and returns the first vector minus the second. Then there's vector2normalize. Here's what normalize does. It takes a vector of a particular length, and it returns a vector pointing in the same direction with a length of 1. Once you take a vector and normalize it, its length is 1, and we call that vector with a length of 1 a normalized vector. There's also vector-to-scale, which takes a vector of a particular size and scales it by the float passed in as the second parameter. So rather than doing math ourselves, we can take advantage of using the math library, RayMath, which allows us to do math in our programs quickly and reliably. So in summary, we've discussed vectors and how a vector is a mathematical concept involving a direction and a magnitude, also known as length. We saw that vectors can represent direction and position, and we can use vectors to quantify movement. We also learned about some vector operations such as addition and subtraction, normalization, and vector scaling. We'll put some of these to use in the next video when we program the ability to move around on our map. I'll see you in the next video.